Today we're in beautiful Monterey, California for the annual BACUS Photomass Symposium. I'm Angie Kellen for the eBeam Initiative, and with me today is Aki Fujimura, founder and CEO of D2S, and expert at building technology companies. Welcome, Aki.
Thank you.
Now, some of today's presentations had examples of complex shapes on mass, including sub-80 nanometer feature sizes. Now, we know that complex masks are going to become more common at 20 nanometers. How are you planning to address the challenge, or I should say the trade-off between mask write times and wafer quality?
Yes, thank you. We introduced today a product called TrueMask DS, and it is the industry's first double simulation platform. By double simulation, what we mean is that as opposed to the bundled models that lithography companies use, where mask models are kind of a simplified corner rounding models, we actually do a full mask simulation, a mask process simulation, followed by a contour-based, a curvilinear contour-based lithography simulation, all in one platform. And by being able to do that, both from the mask perspective, you will be able to get an accurate mask contour simulation-based as opposed to having to write it and measure it, and then be able to see what the impact on the wafer would be. And from a wafer fab or OPC shop's point of view, they'd be able to see what kind of a trade-off is possible between what is what mask shot count is required to write certain shapes and what the impact of that on the wafer would be.
In today's presentation by Globalfoundries, he presented the idea of using eBeam simulation as well as wafer simulation to manage the trade-offs that you would get between mask write times and also wafer quality. Now, what are your thoughts on that? Do you think that eBeam simulation approaches are going to become the mainstream, and at what logic node?
Yes, 20 nanometer logic node is when it would start. The basic issue is that there is a discontinuity at 80 nanometer feature sizes being written on the mask. And when you go below that, as you would at 20 nanometer, SRAFs, or sub-resolution assist features, become maybe between 40 and 60 nanometer, well below the 80 nanometer threshold, where you can no longer count on what you draw in the CAD system being actually written on the mask. Furthermore, because the mask shapes are very complex, and you end up writing what is approximating a curvilinear shape on the mask, and curvilinear shapes, especially at these small feature sizes, become a problem. So simulation-based approach is the only way, I believe, to write 20 nanometer and below masks.
Well, let me ask you another question. Over the past year, the idea of complementary eBeam lithography, also known as cut layers, has gained a little bit of momentum in the press, especially since Jan Brodowski of Intel has, offered his thoughts on that. Also, one of your newest eBeam Initiative members, Multibeam Corporation, is a proponent of this, along with other eBeam direct write players. What are your thoughts about the adoption of complementary eBeam lithography?
Yeah, I think it's a great idea, and I think Jan's suggestion that David Lam has been also signing up to support is reflecting kind of a wisdom about what is practical in this kind of an industry. The eBeam direct write has had the problem of being always a generation or two behind in being able to write the finest features for the last 5-10 years or so. And what Jan's suggesting is, you don't have to write all of the different features, different sizes. Of course, it's best if you could write any shape, but first maybe you can focus on something that eBeam is inherently good at, which is depth of focus and writing small contact features or small cut features, and hide in some ways what eBeam is not necessarily good at, which is stitching the shapes between the different writes. So what CBL, the idea presents, is a way to maybe get to production earlier with this eBeam technique, and this would create the business opportunity for these companies to catch up in one node with this, and then have enough money to go to the next node with the general shape. So I think it's a really good idea.
Well, Aki, thank you so much for your time and sharing your insights with us today. And we hope to be talking with you again very soon.
Thank you.
In Monterey, for the eBeam Initiative, I'm Angie Kellen.